In a kitchen, GFCI receptacles are indeed needed over the countertop. This is especially important near sinks. However, if there are additional countertops that are not connected and an island in the middle, even without sinks, duplex receptacles are still required. The purpose of GFCIs in kitchens is to provide protection against electrical shock hazards caused by water contact, and this protection should extend to all counter areas where appliances or other electrical devices may be used, regardless of the presence of a sink. Now, regarding wiring a shed that is 300 feet away with a 20 amp load, which requires 8-gauge wire due to voltage drop, the proper wiring method involves running the 8-gauge wire from the main electrical panel to the shed. This 8-gauge wire will provide sufficient current carrying capacity, compensating for the voltage drop over that distance. Within the shed, you should wire the 15 amp GFCI receptacle and any other loads with 12-gauge wire. To connect the 12-gauge wire to the 8-gauge wire, you will need to pigtail the connection. Strip the insulation from both the 8-gauge wire and a short length, about 6 to 8 inches, of 14-gauge wire. Connect the 14-gauge wire to the terminals of the GFCI receptacle, as most receptacles are not designed to directly accept 8-gauge wire. Secure the connection between the 8-gauge and 14-gauge wires with electrical tape. This will ensure a safe and reliable electrical connection. Concerning the types of conductors that can be used in conduit, the National Electrical Code, or NEC, specifies various types of conductors that are approved for use in different types of conduit. Firstly, when using electrical metallic tubing, or IMT, you can use THHN, THWN, THHN-2, XHHW, and THW conductors. Secondly, for rigid metal conduit, or RMC, the same conductor types are permitted, including THHN, THWN, THHN-2, XHHW, THW, and also MV-90. Thirdly, when utilizing intermediate metal conduit, or IMC, the acceptable conductors include THHN, THWN, THHN-2, XHHW, THW, and MV-90 as well. Fourthly, liquid-type flexible non-metallic conduit, or LFNC, also allows for the use of THHN, THWN, THHN-2, XHHW, THW, and MV-90 conductors. Wiremold, which is a type of surface-mounted raceway, can be used with THHN, THWN, THHN-2, XHHW, and THW conductors. However, it is important to note that wiremold is not considered a conduit because it is not a solid, enclosed metallic tube. The specific conductors allowed in conduit may vary depending on the type of conduit, the voltage rating, and the ambient temperature. It is always best practice to refer to the NEC and the specific conduit manufacturer's instructions for the most up-to-date information. When wiring a shed with 8-gauge wire for a 15 amp load, you run the 8-gauge wire from the main electrical panel to the shed to provide adequate current carrying capacity and mitigate voltage drop. Within the shed, wire the 15 amp GFCI receptacle and any other loads with 12-gauge wire, as it is suitable for the 15 amp circuit. Pigtail the 14-gauge wire to connect it to the GFCI receptacle, securing the connection with electrical tape. This method ensures a safe and compliant electrical installation. Remember that GFCI receptacles are required for all countertop spaces in a kitchen, regardless of whether they have sinks or not, to provide protection against electrical shock hazards. For conduit installations, various conductor types such as THHN, THWN, THHN-2, XHHW, and THW are permitted depending on the type of conduit being used. Always consult the NEC and the manufacturer's instructions for specific requirements and guidelines. Let's explore GFCI receptacle requirements in kitchens with multiple countertops. The NEC mandates GFCI protection for all receptacles serving countertop surfaces in kitchens. This requirement applies regardless of the proximity to sinks. If you have countertops that are separated or include an island, each countertop area must have GFCI protected receptacles. The purpose of GFCI protection is to prevent electrical shocks, especially in areas where water is present. Therefore, even if a countertop doesn't have a sink nearby, it still needs GFCI receptacles. Next, consider wiring a shed 300 feet away with a 20 amp service. Due to the distance, you correctly determined that 8-gauge wire is necessary to minimize voltage drop. Here's how to wire the shed correctly. Firstly, run the 8-gauge wire from your main panel to a junction box inside the shed. Ensure you use appropriate connectors rated for 8-gauge wire. Secondly, from the junction box, you can transition to 12-gauge wire to feed your 15 amp GFCI receptacle and any other 15 amp circuits in the shed. This is permissible because the 8-gauge wire acts as the feeder, providing the necessary ampacity for the entire run, while the 12-gauge wire is used for the branch circuits within the shed. Thirdly, to connect the 8-gauge wire to the 12-gauge wire, use appropriately sized wire connectors rated for connecting different gauge wires. For example, you can use a split bolt connector or a Polaris connector depending on the specifics of your installation. Avoid simply twisting the wires together and taping them, as this is not a safe or code-compliant method. Fourthly, to connect the 12-gauge wire to the 15 amp GFCI receptacle, use standard wiring techniques. Connect the black hot wire to the brass screw terminal, the white neutral wire to the silver screw terminal, and the green or bare copper ground wire to the green grounding screw. Always make sure the connections are tight and secure. Fifthly, when dealing with a pool pump that has a 15 amp 120 volt cord, ensure the GFCI receptacle you are connecting it to is rated for outdoor use, if the receptacle is located outside the shed. It's essential for safety. Now let's address the question about what types of conductors are allowed in conduit. Your initial understanding that THHN is the standard choice for conduit is correct, but it's not the only option. Your teacher is also correct in that you can use other types of wires in conduit, provided they are appropriately rated for the environment and application. Here's a more detailed explanation. Firstly, THHN/THWN is indeed the most common choice. THHN stands for thermoplastic high heat resistant nylon coated. THWN stands for thermoplastic heat and water resistant nylon coated. These wires are suitable for dry and damp locations and can handle temperatures up to 90 degrees Celsius in dry locations and 75 degrees Celsius in wet locations. Secondly, other approved conductors include XHHW, which stands for cross-linked polyethylene high heat resistant water resistant. XHHW is also suitable for wet and dry locations and is often used in conduit. Thirdly, UF cable is generally not used inside conduit. UF stands for underground feeder and it's designed for direct burial applications. While you could technically run it through a conduit for physical protection, it's more cost-effective and common to use THHN/THWN or XHHW wires inside conduit. Fourthly, ROMIX or NMB cable is generally not allowed in conduit that is exposed to wet or damp locations. NMB stands for non-metallic sheath cable. It's designed for dry, indoor locations only. However, if the conduit is installed in a dry, indoor location, some jurisdictions might allow NMB cable inside the conduit, but this is not a common practice and it's best to check with your local electrical inspector to confirm. Fifthly, when using wiremold, which is a surface-mounted raceway, you typically use THHN/THWN wires. Wiremold is not considered a conduit in the traditional sense, but it serves a similar purpose of protecting and routing wires. Sixthly, when choosing conductors for conduit, always refer to the National Electrical Code, NEC, and local electrical codes. The NEC provides detailed information on which types of conductors are approved for use in different types of conduits and applications. In summary, while THHN is a common and versatile choice for conduit, other types of conductors like XHHW are also acceptable. Avoid using UF cable inside conduit unless there's a specific reason for doing so, and never use NMB cable in conduit in wet or damp locations. Always consult local codes and inspectors to ensure compliance. To reiterate, for kitchen countertops, GFCI protection is required for all receptacles serving the countertop, regardless of the presence of sinks. When wiring a shed at a distance, use appropriately sized wire to mitigate voltage drop and transition to smaller gauge wire for branch circuits within the shed. Lastly, when using conduit, THHN/THWN and XHHW are common choices, but always check local codes and the NEC for specific requirements. The National Electrical Code, or NEC, provides specific guidelines on what types of conductors are allowed in various types of conduit. Here's a detailed breakdown of the most common conductor types and their applications in conduit. THHN and THWN are among the most frequently used conductors in conduit systems. THHN stands for thermoplastic high heat resistant nylon coated, while THWN stands for thermoplastic heat and water resistant nylon coated. These conductors are suitable for both dry and damp locations and can handle temperatures up to 90 degrees Celsius in dry environments and 75 degrees Celsius in wet environments. They are versatile and cost-effective, making them a popular choice for many electrical installations. Another common conductor type is XHHW, which stands for cross-linked polyethylene high heat resistant water resistant. XHHW is also suitable for wet and dry locations and is often used in conduit, particularly in applications where higher temperature ratings are required. It offers excellent resistance to moisture and heat, making it a reliable choice for demanding environments. In addition to THHN, THWN, and XHHW, other conductor types such as THW, which stands for thermoplastic heat and water resistant, and MV-90, which is a medium voltage conductor rated for 90 degrees Celsius, are also permitted in certain types of conduit depending on the specific application and code requirements. It's important to note that the specific conductors allowed in conduit may vary depending on the type of conduit being used. For example, electrical metallic tubing, or IMC rigid metal conduit, or RMC intermediate metal conduit, or IMC and liquid type flexible non-metallic conduit, or LFNC, each have their own set of approved conductor types. When selecting conductors for conduit, always refer to the NEC and local electrical codes to ensure compliance. The NEC provides detailed information on conductor types, ampacity ratings, and installation requirements for various conduit systems. While THHN, THWN, and XHHW are commonly used in conduit, UF cable, which stands for underground feeder cable, is generally not used inside conduit. UF cable is designed for direct burial applications and is typically used for underground wiring. While it can be installed in conduit for physical protection, it's more cost-effective to use other conductor types like THHN or XHHW inside conduit. Similarly, an MB cable, which stands for non-metallic sheathed cable and is commonly known as Romex, is generally not allowed in conduit that is exposed to wet or damp locations. An MB cable is designed for dry, indoor locations only and is not suitable for use in wet or damp environments. However, in dry, indoor locations, some jurisdictions may allow an MB cable inside conduit, but this is not a common practice and it's best to check with local electrical inspectors to confirm. When using wiremold, which is a surface-mounted raceway, you typically use THHN or THWN conductors. Wiremold is not considered a conduit in the traditional sense, but it serves a similar purpose of protecting and routing wires along surfaces. In summary, the choice of conductors for conduit depends on several factors, including the type of conduit, the environmental conditions, and the specific application requirements. THHN, THWN, and XHHW are among the most commonly used conductors in conduit systems, but other conductor types may also be permitted depending on the circumstances. Always refer to the NEC and local electrical codes for detailed guidance on conductor selection and installation requirements. Remember, GFCI protection is required for all countertop spaces in kitchens, regardless of the presence of sinks, and when wiring a shed at a distance, use appropriately sized wire to mitigate voltage drop and transition to smaller gauge wire for branch circuits within the shed. Furthermore, when using conduit, select conductors that are approved for the specific type of conduit and environmental conditions.